Hi everyone, this is the lesson for day 2 of Similarity from section 6.3 of your textbook. And last time we talked about, if you remember, how to use and figure out which definitions for shortcuts were valid for two triangles that we thought were similar. We talked about how to use them in the proportions, and in this lesson we're going to be talking about just simply verifying whether they're similar or not. It's really important that you understand not to assume anything. This was true when we were doing congruence shortcuts, if you remember, and this was really a pitfall that a lot of you guys fell into the trap of. So really don't assume anything, okay? If you see measurements that look like, yeah, sure, they might be similar, and remember we're going to be looking at the magic 3 shortcuts that we talked about last time, which is angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Remember, you need to verify the math, especially if there's an S in that shortcut, one of these two right here. Then you need to make sure that you're showing the math that proves that those ratios are equal. Don't assume anything, okay? So on this worksheet, which is your CUDA software worksheet that you have in front of you, we're going to work through these first 6 problems, and then I'm going to give you time to work on the back side. Mr. Wyman, your substitute, is going to have the answers for you for problems 7 through 12, and then he'll be giving you the assignment from your textbook for tonight. So without any further ado, here we go. Let's zoom right in on this first problem. And we can assume, as we're looking at number 1 here, we see 2 sides and we see the angles in between. So of course we can start by marking those angles congruent because they're vertical angles. And so our question might be to ourselves, is this a side angle side similarity problem? So what we need to check out is the ratios of those corresponding sides going to be equal? So you guys, I'm going to start just by when I have a 2 sides in my proportion like this, I'm just going to take the small and the larges and put them into a fraction. And then I'm going to ask the question, are they equal, those ratios? So the small sides here are 16 from that top triangle and 39 from that bottom triangle. And then the large sides are 16 from the top triangle again, and the large side on the bottom is 40. So I think you can pretty much tell pretty quickly here that you're going to get 2 completely different decimals. If we did the decimal on this side with our calculator, we get 0.41, and that is not equal to 16 divided by 40, which is 0.4 exactly, or 0.40. So this is one way to check, of course, that that's not a ratio that works out. Another way to do it is simply to cross multiply, just like we did with our proportions when we were finding x in the last lesson. So we'll do 16 times 40, and we get for that 640. And that is not going to be equal to, if we go back to the other way, the 39 times 16 is going to give me 624, which of course is another not equal to situation. So this one we would say is not similar. And anytime you're saying not similar, of course, there's no way to be filling in that blank of what it's similar to. So that's where we're at for the first problem. Now we're going to go back over to problem 2, and we are tempted here to see, of course, 3 sets of sides. So we're going to maybe think that this might be a side-side-side similarity, but because there's an S in the shortcut, like we talked about, we have to verify the math. So with these 3 sides, I usually do a small, medium, and large. Think like go through McDonald's, okay? You're going to take the 2 smaller sides, which were 48 from that left-hand triangle, divided by 8 from the right-hand triangle. And the question is that going to come out equal to the medium sides ratio, which is 72 to 12? And also, is that going to come out to be equal to the ratio of the large sides, which is 84 to 14? And if we do a quick division on these, we get actually 6 as an even division for all three. So because those are all equal, then we can go ahead and say that this is similar by side, side, side similarity. And that what we need to do now is to make sure that we finish this similarity statement in this blank right here, and that we make sure that the letters are put into corresponding order. So side C, if you look, is across from that middle length side. So we want to find the middle length side over in this triangle, which is 12, and go across from it. And so my first letter should be F. Make sure you put your triangle symbol, F. Then to go with B next as my middle letter there, B is opposite the longest side. So we want to go opposite the longest side, and that's going to be G. And then finally we have the final vertex of H. So that's what we should see for those first two problems. And then we're going to go on to number 3. You guys can pause this video anytime you need to, remember, if I'm going too quickly and you need to catch up with notes. Okay, next we're going to zoom back in on question 3 here. And this one, as we look at it, we guess that it might be a side angle side similarity shortcut, and that's because we can definitely see those vertical angles marked there. But because we're not sure whether the sides are in ratio, we need to set that up. So again, there's only 2, so we're going to just set up a small and a large, and make sure that the small sides, which are 8 and 28, are in the same ratio. That's the question. Is that in the same ratio as the large sides, which are 14 and 49? And again, we can verify this in 2 ways. We can go ahead and find the decimal, and we actually get, it's an approximation, but it's the same exact approximation on each side. It's not quite exactly equal to, as we think here with our straight equal sign normally, but I'll just not put as many decimal places for you guys to simplify here. But if we went in and did the cross multiplication of this proportion, we would get exactly 392 equals 392. So again, you want to make sure that it checks out, whether it's the decimal version of the check that you use or whether it's the multiplication version of the check, but you want to make sure that it's definitely shown in your work for me to give you full credit. This one, as you can see, does come out to have a side angle side similarity. So we can go ahead and write that in, and then again we want to make sure our vertices are in corresponding order. So VUT is going to correspond, I hope you can see, make sure you have your triangle symbol again, with VLM. Okay, awesome. We're half done the examples on this page. Let's keep moving along here. On number 4, I hope you can see this one's going to go really quickly, you guys. We see one set of congruent angles. Of course, we've got our one set here and here, and then we've got our another set here and here. So this one actually doesn't even require any ratio work. Yay, no ratio work needed, because this one is an angle-angle similarity, and like we talked about, there's no S in this shortcut. So since there's no S in this shortcut, there's no math work that has to be shown. This should become your favorite similarity shortcut because it requires the least amount of work of any of them. So if we go over to number 5, as we start to mark even just vertical angles here and here, and if we were to go ahead and actually we need to make that different markings, looks like we need 4 of them there because we've already got 2 tick marks here, 3 tick marks here, and 1 here. And this is not necessarily guaranteed. This vertical angle set is not necessarily guaranteed to be the same as the others. So I'm not seeing any angle pairs that are congruent here, and so we would just simply say not similar. And anytime you're writing that not similar, remember, you're just going to go ahead and just put an X through that blank because you don't need to fill it in at all. Okay, our last problem, here we go. This one's a little tricky, so I want to give you a pointer here as far as how to think through this one. What I would do on this problem, because I think you can see that there's a small triangle here that is overlapping the bigger triangle, but it's sharing this angle K. So what I would do if I were you is I would redraw these two diagrams completely and make sure that you relabel it the way that you need to. So if we have K, B, C, the smaller triangle here, and then we have K, M, and L as far as the vertices of that bigger triangle go, then I need to make sure I transfer the markings from the diagram up here to the correct places down into my separated drawings down here. So once I do that, you guys, you just need to either add or subtract depending on what those, whether it's an overlap or whether it's a partial piece that's shown. You just kind of have to really reason through that as best you can. So I can see in KB is 16. I can see KL, that whole length that's got the blue arrow there, is marked, and that's given to me as 88. I can see KC is 25. And I can see if I were to add this 25 here and the 107, that's going to give me the full length from K to M. So I'm going to go ahead and add that up, and I get 132. Now, because I have my similar triangle shortcut that appears to have side angle side, I'm going to go ahead and check that out, whether it's a side angle side similarity shortcut or not. And to do that, we're going to plug in the numbers into our ratio. We've got small and large again of the sides there. The question is, does 16 over 88, because those are the two smaller sides, does that end up being equivalent to the ratio of the large sides, which is 25 to 132? And if we do our cross multiplication or our division there with our calculator, division with the decimal gives me this is 0.18 exactly, and it's actually repeating. And it does not come out to be equal to a decimal that has 0.189 and a few other digits going on there. And then again, we could also verify it. The cross multiplication would be 2,112, which does not come out to be 2,200 on the other side. So on this one, again, we're going to finish by saying not similar. Even though it might have looked like it to begin with, we're not assuming anything, remember, from our slide from before. And because it's not similar, we are not filling in that second blank. So those are the first 6 problems. Again, you can go back and rewatch any part of that you need to if I talk too fast, but hopefully that'll give you an idea of what you're headed towards for your homework. You need to go back and flip over to the other side of this CUDA worksheet now and complete problems 7 through 12, and then go ahead and bring that up to Mr. Wyman, and he's going to have the answers for you to check, and then he will give you your assignment for this evening. Thanks, guys. I hope to see you soon.